So the Pythagorean theorem identity section, we've kind of talked about this a little bit. We're just using cosine squared plus sine squared equals 1. I mean, that should make sense. Your Pythagorean theorem is a squared plus b squared equals c squared. So we say your cosine squared plus sine squared technically equals 1 squared is called Pythagorean identity. Identity just means it's true for every single value. No matter what angle we're talking about, this will work for every single angle theta. Now, for example 10, I'm going to show you two different ways. And if you want to watch and then choose the way, or if you want to write both ways just in case, we're going to start with the way the book does it, and then I'm going to show you another way. So this one starts with this identity, cosine squared plus sine squared equals 1. We know that sine equals 2/3. So I'm going to substitute 2/3 in place of sine. Then I'm going to square it. Subtract 4/9 from 1 to get 5/9. Square root both sides. Cosine equals, when you square root the equation, you need the plus or minus. 5 I cannot take the square root of, but 9 I can, and that's my final answer. Now personally, that works for me, but let me show you another way. First of all, this is a positive value, a positive 2/3, so let me place it in the first quadrant. Where else is sine positive? Remember, all students take calc. So sine is positive in the first and the second. So I'm going to create two triangles. Sine is y over r. So I'm going to put the y value as 2 and the r value as 3 in each triangle. Now, how do I find the third side of a right triangle? A squared plus b squared equals c squared. So a squared equals 5. So a equals plus or minus square root of 5. So this is the positive square root of 5 because I'm going to the right. This one is the negative square root of 5 because I'm going to the left. So as soon as you set up your triangles, what is cosine? Cosine is x over r. And so we end up with plus or minus square root of 5 over 3, which is just like that. So it's technically doing the same thing. It just depends on your preference. Now, I think the second example is much easier my way. First of all, they give you a window. The interval of the angle is between pi and 3 pi over 2, which means the angle is in the third quadrant. This is telling us quadrant 3. So I'm just going to connect my terminal side to the x-axis. Sine is y over r. Y is the negative. R is always positive. Always make sure the hypotenuse is positive. How do I find my missing x? Negative 3 squared. I'm just going to say x squared. It doesn't matter. So this is 9. This is 16. So x is a square root of 7, but it's just the one going left, so it's just the negative 1. And what is cosine in this triangle? Cosine is x over r. Tangent is y over x. Now, I don't care necessarily if you fix the denominator, but whenever you have two negatives, make sure you simplify that. And that's your answer. Okay. 3, always focus on the interval first. Theta is between 3 pi over 2 and 2 pi. So this one is in the quadrant 4. All right, tangent is -2. I always just create my fraction because this is y over x. So the y is -2, the x is 1. So now I'm going to do 1 squared plus -2 squared equals my radius squared, or c squared, I don't care what variable you use. Because r is always positive, this is the square root of 5. As soon as you know your x, y, and r, you can find all trig ratios. Exact answers are the ratios. Sine is y over r. Cosine is x over r. And that's it. So to me, I like setting the triangle up, and then you can find all your trig values. And that's it.